probability, right? Once we had a detailed understanding of measures of central tendency, spread, skewness, and doing a basic diagramming and displaying the data in the form of table. Now we are moving into the core aspect of this subject, which is the probability. And a basic thing which we need to know before we understand the probability is a basic set theory. So some kind of probability questions can easily be answered once we have a decent understanding of the set theory and Venn diagrams kind of stuff. So that is one place where we can look at it as a part of the first part of this chapter. So just a quick brush up. I think in simple way I define a set is nothing but a collection of objects. So why do we use that in our probability world? In our probability world, actually we talk about number of outcomes, right? Number of outcomes is nothing but a set. So that's the reason we need to understand this world of sets, wherein we are talking about any set is a collection of objects. Probably it is represented something like, okay, a collection of 1, 2, 3, 4 numbers is a set. Probably this is a set of numbers less than 5. Right? So set is a group like this, and every element in this set. So let's say when I throw a dice, the outcomes which the dice can give me, that's a set. Probably the outcomes that I can get when I throw a dice are 1, 2, 3, 4, 5, 6. This is a set. Out of this set, each element or each item of that set, probably if I am saying 2 I call as the element of this set, right? So the sets are generally recognized by some letter. They are mentioned by some letters, and every element is each item is an element of that particular set. And one more thing which we need to understand is the subset. Typically it is represented as A is a subset of B. So which is clearly telling me that if every element of A is present in B also, then we say A is a subset of B. So in this case, let's say if I am looking at this as A and this as S, every element of A is present in S also. So that is where here I can create a relationship saying A is a subset of S for this example. And if at all any set does not have any elements, it's a blank. Blanks are generally shown either like this or even with a 5. Any set like this, it's not that we should not put a bracket here. This is not an empty set or a null set, because this contains an element called 5. Either I represent it with a blank, no element in the brackets, or I represent it blank like a 5 without any brackets around it. These are all called as null sets.